I'm actually going to give a full talk about this at a typesetting conference in 2 months, but for this particular audience, a lightning talk will be more than sufficient, as you will soon discover. So as part of my research on typesetting experiments, I have developed a library for parsing the text font matrix format, TFM, which is the original historical file format that the text typesetting system uses. Of course, when you develop a parser, you want it to be extremely robust as possible. So there is a bunch, actually, hopefully an exhaustive set of errors and warning and all that stuff in order to be able to catch every possible situation that can go wrong during the parsing of the files. And also in order to be as gentle with the outside of the system as possible. There is also a quite rich, although as of today, not non-interactive set of restarts, which allows you to recover as gracefully as possible from any potential problems occurring during the parsing. Just to give you a quick example, there is a thing in the TFM format which is called a fixed word. It's actually an integer, but in some cases, there is a limitation on the possible values, and so it has to be constrained within -16 and +16. If you look at potential occurrences of the fixed word in the file and potential things that can go wrong, when you're located at the very lowest level here, the function to read a fixed word from the file is called read fixed word, and if you only know that, there is not much you can do in terms of recovery apart maybe from setting it to a default value, which probably is going to be harmless, like set to 0. But if reading the fixed word comes from reading a ligature or kerning table, then you could maybe think that probably the whole table is going to be corrupt, so you can just drop the whole thing. On the other hand, if the table is okay, but if you're currently decoding a ligature or kerning program, you might just want to discard this corrupted ligature or kerning program instead of the whole table. And finally, the top level function is called load font. And every time anything goes wrong during the loading, you also have the ability to restart by saying just let's forget about the whole font file and so cancel loading. If something goes wrong interactively, so you enter the debugger, and as you can see, you can see the different restart possible here. What I want to explain here is that if by looking at the backtrace, you can also have some bits of useful additional context. So for instance, in this situation, the backtrace tells you that the problem reading the fixed word occurred when you were parsing a character information. So this is an additional and useful piece of information, but of course, this has to occur when you are interactively loading the TFM file. Most of you, probably all of you know the benefit there is in using the common Lisp condition system. The main advantage in terms of expressiveness in the system is that as opposed to traditional catch-throw mechanism, you have a three-dimensional separation of concerns. What I mean by that is that in the regular classical systems, every place you catch an exception is also the place where you need to restart from. But in the common Lisp condition system, you can signal stuff, you can place restarts, which are possibility to recover at certain positions in the code. But if you establish a handler can be yet somewhere else and choose to restart at another position. So this is really a three-dimensional separation of concerns. And this is of a great help in many situations, including this one. So suppose, for instance, that I'm calling load font, but on top of this call, I will establish that gigantic handler bindings, or set of bindings actually, which is going to collect all conditions potentially occurring while executing the function load font. So collect the conditions, and then instead of aborting the process, select a restart, preferably the softest one, in the sense the one that would let me go as far as possible in the parsing of the file, okay? And then once this is done, I collected all the conditions that occurred during the parsing, and then I can just return them, okay? So essentially, this is a bit tedious to write, but this is really not complicated. It's just a matter of installing a gigantic handler bind call on top of the function that you want to call, okay? And what do you get if you do that? You get a syntax checker, and that's all, okay? So there is nothing complicated for us. But as Stavros was saying this morning, this is an accidental project. It means that that was not the original intention, but this is an interesting side effect, because if you can do that, you can potentially syntax check a whole bunch of files. And I want you to meet TFM validate, which is a library which I wrote actually just last month. It's already available on GitHub. It's a library which calls the TFM load font function, and it generates compliance reports for TFM files. Okay, so you have a function which will just check a file, and there is now also a function which checks the whole TechLive distribution, and generates a website with all the compliance reports. In other words, all the files that went wrong. So let's look at the website. It's here. So as you can see right now, it has checked. It takes approximately 2 minutes to run, and it checks a little less than 80,000 fonts in the TechLive distribution. And currently, it finds almost 700 non-compliant TFM files in the TechLive distribution. So there's a bunch of them. If you read this one, for instance, okay. So that's not the one. Sorry. I shut down the internet. That's the reason why. Well, anyway, you get the idea. So I'm gonna just skip that part. So this is actually the end of the talk. And at that point, you still don't understand why I entitled it Please Decline. This is going to be explained in part 2 of this talk, which will happen tomorrow, because yes, I managed to sneak in a 10 minutes lightning talk at ELS this year. Thank you very much.